Hi there, this is Zero Munduluru. So we have seen that software developed using compiled languages like C are not platform independent. Now let's look at interpreters, which address the platform dependency issue but have some other limitations. It's an interesting lecture, and sometimes even senior engineers do not really know how interpreters work. But that would not be the case for us. We know that in a compiled language, machine code is first generated by the compiler. And the generated machine code is then separately executed by the CPU. An interpreted language works differently. In an interpreted language, we have an interpreter, which is a program that directly executes the source code. That is, there is no separate compilation and execution step like in the case of a compiled language. As you can see here, input to the interpreter is the source code, and output is the result of execution of that source code. So you can see the similarity between an interpreter and a CPU. A CPU turns machine code into results, while an interpreter turns source code into results. So machine code serves as the instruction set for the CPU, while source code serves as the instruction set for the interpreter. Just note that interpreter is also a program and it needs to be run. So CPU executes the interpreter and interpreter in turn executes the source code. So interpreter is nothing but a virtual machine that simulates a CPU. That is just the way a CPU executes machine language instructions using the fetch and execute cycle. An interpreter also executes instructions in the source code in a similar fetch and execute cycle. Let's now look at how a computer's fetch and execute cycle works. Fetch and execute cycle is the most fundamental operation of a computer, and every programmer must know it. In case you're not familiar with it, this brief discussion should be helpful. Now here we have a CPU, memory, and a hard disk with a program to be executed. When the program is executed or started, the program first gets loaded into memory. And we know that a program is the machine code and is basically a sequence of instructions where each instruction is simply a sequence of zeros and ones. Next, CPU fetches an instruction from the memory and it then executes it. And in the process, it may also fetch any data needed to execute the instruction. Any data generated by the execution of the instruction will be written back to the memory. CPU then fetches the next instruction and executes it. So this cycle continues until all of the instructions in the program are executed. So that's basically the CPU's fetch and execute lifecycle. Now let's look at interpreter's fetch and execute cycle. Like a CPU, interpreter also fetches its instructions from the memory. However, in interpreter's case, the instruction is basically a statement in the source code. It then understands what is necessary to carry out that statement. And these two steps are also done by a compiler. Next step would be to execute the program statement. And here is the interesting thing. Interpreter maintains a library of compiled machine code, and it just executes the appropriate compiled machine code that corresponds to the program statement. So the interpreter is not generating machine code. It simply uses its own compiled machine code to accomplish what the source code directs. Let's actually look at an example. Here we have an add statement in the source code, and the interpreter executes the corresponding compiled code from its library, which is the machine code version of this block of code that you see here. The code is fetching the two numbers to add from the memory, and then is performing the actual addition and is finally storing the output back in the memory. So once again, interpreter is not generating machine code. It just uses its library of pre-compiled machine code. One main advantage of interpreter is platform independence. As you can see in this illustration, the same source code can be executed on any of the platforms. Only requirement is to install an interpreter specific to the platform. Recall that with a compiled language, we could not achieve platform independence. That was because instead of source code, we were using machine code, which was platform dependent. That is, the machine code includes attributes specific to the platform on which it was generated. So the target platform on which the machine code is to be executed could have different set of attributes, and thus the machine code would fail to execute. But with an interpreted language, we are executing source code, which is identical regardless of the platform on which it is written. That is, it is platform independent. It is just that the interpreter on the target platform ensures that the platform independent source code is executed without any issues. Now let's look at the pros and cons of an interpreter. One advantage of an interpreter include platform independence, as we have just seen. Next, there is no compilation step. That is, a program execution can start immediately. I think one main advantage of not having a compilation step is that it would enable easier updates. For example, in some of my projects, there were instances where I had to fix bugs in the JavaScript code on production servers. JavaScript is an interpreted language, and so I could easily make the required code changes directly on production servers, which saved me a lot of time. Now, had it been a compiled language, I would have to make the changes externally, compile the code, and then deploy the compiled code onto production servers, which would consume a lot of valuable time. Now, in terms of limitations, interpretation is orders of magnitude slower than compiled code. There are a couple of reasons for this. One is due to costly memory access operations. For example, this is the library code from the add instruction example which we saw earlier. As you can see, there are several costly memory access operations. In a compiled language, it would have been taken care of in registers, which could result in code that runs very fast, probably even 100 times faster. Second reason for slowness is program has to be reinterpreted every single time it is run. Another limitation is that interpreter is loaded into memory along with the source code. So you have an extra program that is getting loaded into the memory. I don't think it's a big deal, but it is just something we need to know. So as we can see, though interpreters solve the platform independence issue, they do have other limitations like slow execution speed. We will next see how Java takes care of the speed issue without compromising on platform independence. Thank you.